Hello friends, welcome back to the class. In this video, we are going to discuss about PMO theory. So, perturbation molecular orbital theory or aromatic transition state theory for cyclo addition reactions. So, here friends, in this theory, so we already discussed that the PMO theory mainly based on the nature of transition state. So to write the transition state, first we have to select, we have to select psi1 molecular orbital of individual pi partners. So for best combination, because when you take psi1, the giving representation is very easy because all lobes present at the top side, you can take a plus sign. By default, the bottom lobes have minus. Then show the cyclic array of atomic orbitals. Show cyclic array of atomic orbital in the transition state. So next, classify the transition state into aromatic or anti-aromatic. Aromatic or anti-aromatic. Friends, if you get aromatic transition state, that is thermally allowed, anti-aromatic transition state, that is photochemically allowed. So how to know the aromatic transition state? So it is very easy friends. When in the transition state, if nodes equal to 0 or even number, this is called Huckel system. What we say? Huckel system. Okay. So for Huckel system, 4 and pi electrons are present in in the transition state. 4 and pi electrons are present. That is anti-aromatic transition state. Anti-aromatic transition state. If it has 4 and plus 2 pi electrons, 4 and plus 2 pi electrons, this is called aromatic transition state. So number of nodes are 0 or even, that system is called Huckel system, and the pi system belongs to 4 and pi, that is called Huckel anti-aromatic transition state. If the pi system belongs to 4 and plus 2 pi electron, then that is called Huckel aromatic transition state. Similarly, if number of nodes are odd, then this system is called the Mobius system. This is called a Mobius system. For Mobius system, if the reaction belongs to 4 and pi cycloaddition, the transition state is Mobius aromatic transition state. What is that? Mobius aromatic transition state. If the system belongs to 4 and plus 2 pi electron cycloaddition, this is called Mobius anti-aromatic transition state. Mobius anti-aromatic transition state. So friends, I hope you understand the concept. So if you have any doubt, you just go through the PMO theory of electrocyclization. There we simply classified the pi systems as well as the transition states. Okay, let's go to the concept. Now the first reaction is 4 and pi cycloaddition reaction. It is also called as 4 pi 2 pi cycloaddition, also called as 2 pi 2 pi cycloaddition. The best example is dimerization of ethylene. This is, I am saying, for our convenience, donor. So plus we are taking an acceptor, so react with acceptor. Then first it forms a cyclic transition state, then it leads to formation of product cyclobutane. So friends, for our convenience, both are ethylene molecules. The first one I am saying is A ethylene, Second one I am saying as B ethylene. So next we have to select psi 1 from A ethylene, psi 1 from B ethylene. So right the psi 1 molecule is right here, right the psi 1 molecular orbital of donor, psi 1 molecular orbital of donor. Two orbitals are present, both are having plus signs, top side minus signs at bottom side. Now take the psi 1 molecular orbital of acceptor, the same thing only, but again we are writing yes, okay. So these are the molecular orbitals of donor ethylene as well as acceptor ethylene. So now you take supra mode of addition. The first one is supra mode of addition. So in this case, select the psi 1 molecular orbital. See friends, for A molecular orbital I am taking reversely. I am taking plus signs at the bottom side. So this is A molecular orbital of A, that is nothing but psi 1 molecular orbital. Second one is psi 1 molecular orbital of B. Yes, psi 1 molecular orbital of B. You see friends, what is the mode of addition? You can observe here, supra mode of addition. That means A undergoing suprafacial addition, B also undergoing suprafacial addition. For that I am selecting these two lobes, the bottom side lobes involving in reaction or bond formation, that is a supra mode of addition. This is also undergoing supra mode of addition. Here also I am taking top side lobes, both are at same side, again that's why it is called supra mode of addition. Now connect these two, yes, connect these two, yes. Now complete the transition state. So connect the bottom side lobes, yes, connect here top side lobes. So now the transition state has completed. So now friends, what you have to observe, so number of nodes in the transition state, because we are discussing about PMO theory, it is very important to identify nodes. You see, there is no plus after minus, all pluses are connected. You can observe plus. Therefore number of nodes are 0. Number of nodes are 0. So we already know that. So nodes are 0 or even number. Nodes are 0 or even number. That system is called what? Huckel system. So the system is called Huckel system. Therefore the system is Huckel transition state. So what is the type of addition? 4 and pi cyclo addition. For Huckel system, 4 and pi. So type of electrons is 4 and pi. That is anti-aromatic transition state. So here friends, the system is Huckel system. Electrons are, sorry, the reactant belongs to 4 and pi cyclo addition. Therefore the transition state is Huckel anti-aromatic transition state. When the word anti-aromatic is present, that is photochemically allowed. Already we know that dimerization of ethylene always takes place at a photochemical condition. So supra mode of addition always takes place at a photochemically allowed. Okay, second one, yes. So supra antra mode of addition. So now friends, the first pi partner is undergoing this one supra mode of addition, because here what is written supra. Second pi partner undergoing antra mode of addition. So for that select these two molecular orbital, sorry, lobes of molecular orbital. This is undergoing antra mode of addition, therefore you have to take opposite side lobes. Now I am selecting these two lobes. So connect all these two. First connect these two, yes, then connect these two, yes, then connect this one to minus lobe, yes. Now right, to complete the transition state, connect these two. So here you can also connect here, no problem. If you connect here also, it will give the same answer. So for best representation I am connecting here. So now you identify the nodes friends. Here you can see plus, connected to plus, connected to plus, connected to plus, but this orbital is connected to minus. So this is a node. So cyclic node, here node is present. So you can have your doubt, sir, here plus is connected to minus, but one thing friends, this complete molecular orbital belongs to this atomic orbital. So this atomic orbital, so now here this atomic orbital not have the node. So when one atomic orbital adjacent by or connected by negative sign followed by plus sign, that is called node. Here this belongs to one atomic orbital, therefore we cannot call this is a node. Okay. So now number of nodes in the transition state is 1. When odd number of nodes are present, that is called Mobius system. What is the type of pi electron? 4 and pi electrons. For Mobius, 4 and pi is aromatic. For Mobius, 4 and pi is aromatic. So when the transition state is aromatic, that is thermally allowed. What is thermally allowed? Supra-antra addition is thermally allowed. So friends, I hope you understand the concept. Now let's go to the next concept, antra-supra mode of addition. So that means the A partner is undergoing, yes, A partner is undergoing antra mode of addition, B partner undergoing supra mode of addition. So first right, pi partner undergoing antra mode of addition. That's why I am selecting this lobe and this lobe, opposite side lobes. So this is undergoing supra mode of addition. Now selected same side lobes. So connect these two. Okay, connect here. Okay, to complete the transition state. Now here you observe. So we selected these two. Yes, connect here and connect here. Complete the transition state. This is the cyclic transition state. Again, you can observe here. What is there? Plus connected to minus, that is a node. So again you can observe friends, note here this is belongs to one atomic orbital, that's why you cannot say this is a node. Okay, right. So number of nodes are 1, odd number, Mobius transition state, pi electrons are 4 and pi. For Mobius, 4 and pi is aromatic, therefore the transition state is Mobius aromatic transition state. When aromatic transition state is present, that is allowed under thermal condition. Allowed under thermal condition. So now let's discuss at last one, antra mode of cycloaddition. That means first pi partner is undergoing, yes, the first pi partner undergoing antra mode of addition, second pi partner is also undergoing antra mode of addition. So both pi partners are undergoing antra mode of cycloaddition. So you have to select opposite side lobes. Here I am selecting opposite side lobes. Here also I am selecting opposite side lobes. Now connect these two. Okay, right. Now connect these two same side lobes. Now connect these two. Yes, antra mode of addition. To complete transition state, connect here. Right. So now you identify the number of nodes in the cyclic transition state. Plus, minus, plus, sorry, plus, 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 plus. Here also you can see minus, minus. Therefore, number of nodes are 0. Number of nodes are 0. So here this is belong to one atomic orbital only. That's why you cannot say node here. This is also belongs to one atomic orbital. That's why you cannot say here no node. So when one atomic orbital connected to another atomic orbital, then you have to identify whether the node is present or not. So when 0 number of nodes are present, that is called Huckel system. So type of pi system is 4 and pi. For Huckel, 4 and pi is anti-aromatic. So therefore it is Huckel anti-aromatic transition state. When the word anti-aromatic is there, that is photochemically allowed. So friends, finally what you identified here? So supra is photochemically allowed. When supra is photochemically allowed, by default antra also photochemically allowed. Antra also H nu allowed. So when supra is and antra is, sorry, antra supra is thermally allowed. So let's see Woodward-Hoffmann selection rules. Yes. So for that, type of cycloaddition, mode of addition, and type of transition state or nature of transition state, allowed condition. So for first, the type of transition cycloaddition is 4 and pi cycloaddition. Mode of addition is supra-supra. So in supra-supra mode of addition, we got Huckel anti-aromatic transition state. Huckel anti-aromatic, when the word anti-aromatic is there, that is photochemically allowed. Therefore, supra-supra mode of addition is photochemically allowed. Supra-antra given Mobius aromatic transition state. Aromatic word is there, that is thermally allowed. Okay. Next, antra supra also gives Mobius transition state, thermally allowed. Antra is also giving Huckel transition state, that is anti-aromatic transition state, photochemical allowed. So remember friends, always dimerization of ethylene takes place photochemically. That's why supra-supra mode of addition is always photochemically allowed. When supra-supra photochemically allowed, antra also photochemically allowed. The remaining are thermally allowed. Thank you friends. So next concept is yes, PMO theory of 4n plus 2 pi cyclo addition. So what is the best example? Diels-Alder reaction. The best example is Diels-Alder reaction. We are taking diene, 1,3-beta diene, dienophile. The dienophile is ethylene molecule. These two are first forms a cyclic transition state. This leads to formation of a cyclic adduct, cyclohexene. What is the product? Cyclohexene. So now you see, we need psi 1 molecular orbital of diene, psi 1 molecular orbital of ethylene, because two molecules are there. To explain PMO theory, we need psi 1 molecular orbital. Now select psi 1 molecular orbital of 1,3-beta diene. So all plus lobes for our convenience I taken at bottom side. Okay, all minus lobes taken at top side. No problem. That is also right. Okay. So now psi 1 molecular orbital of ethylene. So yes, we have positive signs at the top side. Now the first one is 4 pi s plus 2 pi s. That means first pi partner. This is psi 1 of diene. Next psi 1 of dienophile. So this is the supra partner. Therefore undergoing supra addition. And here also second one is also supra addition. So to that, so select here. I am selecting the bottom side lobes, then it is undergoing supra mode of addition. Here I am taking S top side lobes, supra mode of addition. So connect these two. Now connect all bottom side lobes. Now connect these lobes and complete the transition state. Now we got the cyclic transition state. So number of nodes you can identify friends, plus 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 plus. There is no plus minus connection, that's why number of nodes are 0. When number of nodes are 0, yes, when number of nodes are 0, that system is called Huckel system. So Huckel, what is the type of cycloaddition the pi system belongs to? How many pi electrons are there? 6 pi electrons. That means this is 4n plus 2 pi cycloaddition. So for Huckel system, 4n plus 2 pi electrons, that is Huckel aromatic transition state. The transition state is Huckel aromatic because Huckel 4n plus 2 belongs to aromatic. Huckel 4n pi belongs to anti-aromatic. When the word aromatic is there, that is thermally allowed. So supra mode of addition, thermally allowed. So friends, this is about supra mode of addition of Diels-Alder reaction. Let's go to the supra antra mode of addition. That is, yes, here, diene undergoing supra mode of addition, dienophile undergoing antra mode of addition. So supra mode of addition, that's why I am selecting these two lobes. Antra mode of addition, I am selecting opposite side lobes in dienophile. So now connect these two. So connect all bottom side lobes and connect this plus lobe and this minus lobe, because antra mode of addition. To complete transition state, connect here. If you connect here also, that is gives same answer, no problem, you can also try. So right here, okay. So now you see friends, the transition state has obtained. uh, Again you can observe plus 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 plus, but here plus is connected to minus, therefore number of nodes are 1. Here node is present, so number of nodes are 1, odd number of nodes, therefore the transition state is called Mobius transition state. The pi system belongs to 4n plus 2. For Mobius, 4n plus 2 is anti-aromatic. What is that? Anti-aromatic. So when it is anti-aromatic transition state, that is photochemically allowed. So friends, 4n plus 2 supra-anthra is allowed under photochemical condition. The same concept you can explain for anthra supra. So diene undergoing anthra mode of addition, dienophile undergoing supra mode of addition. So that's why I am selecting opposite side lobes for the diene. So same side lobes for dienophile. So connect these lobes and connect all bottom side lobes, yes, and connect these two lobes, yes. To complete transition state, connect here. Again you can observe in this transition state we have a plus minus connection between the orbitals, so therefore it is a node. So number of nodes are 1, nothing but odd number of nodes. When odd number of nodes are present, that is called Mobius transition state. Mobius transition state, okay, the pi system belongs to 4n plus 2 pi electrons. Therefore, for Mobius, 4n plus 2 gives anti-aromatic transition state. Mobius anti-aromatic transition state. This is photochemically allowed. That means anthra supra also photochemically allowed. The last concept is anthra mode of addition. So diene undergoing anthra mode of addition, dienophile also undergoing anthra mode of addition. Okay. For that, I am selecting opposite side lobes in the dienophile and opposite side lobes in diene. Now connect these two lobes, okay. Connect all bottom side lobes, okay. Connect these lobes, okay. Now complete the transition state. You observe friends, here these two orbitals are connected by minus. So all orbitals are connected by plus. Therefore, number of nodes is equal to 0. There is no orbital connected in opposite signs, plus minus. So therefore, number of nodes equal to 0. So number of nodes are equal to 0. The transition state is Huckel transition state. Huckel transition state, pi electron system belongs to 4n plus 2. For Huckel, 4n plus 2 is aromatic transition state. When the word aromatic is there, that is thermally allowed. So friends, what we identified for Diels-Alder reaction, supra mode of addition and anthra mode of addition are thermally allowed. The remaining are photochemically allowed. So you remember friends, always the Diels-Alder reaction takes place at thermal condition. Dimerization of ethylene takes place at photochemical condition. So let's see Woodward-Hoffmann selection rules. Yes, cyclo addition. Yes, mode of addition. Nature of transition state, allowed condition. 4n plus 2 pi cyclo addition. The Diels-Alder reaction you can also call 4 pi 2 pi cyclo addition. Supra the transition state obtained Huckel aromatic transition state. Huckel aromatic always thermally allowed. Supra anthra Mobius anti-aromatic, photochemically allowed. Anthra supra Mobius anti-aromatic, photochemically allowed. Anthra gives Huckel aromatic transition state, that is thermally allowed. Friends, so this is about cyclo addition reactions. We completed CMO theory, FMO theory, PMO theory. So friends, one thing, you just collect the examples from the book. I will upload the book into your group. So which book I am referring here? So I hope you understand the concept of cycloaddition reactions, and I already uploaded the notes till here. So we will meet in the next class. Thank you.